Rome did not invent the clean city. That honor belongs to civilizations lost to time. We often picture gleaming Roman aqueducts and baths as the dawn of urban hygiene. But that story ignores a deeper, more fascinating truth. Millennia before the Caesars, vast ancient megacities thrived with populations in the tens of thousands. From the baked brick labyrinths of the Indus Valley to the monumental avenues of Mesoamerica, these early urban centers faced the same relentless challenge: how to keep a dense population healthy without modern science. Their survival depended on solving a fundamental mystery: managing water and waste on a colossal scale, long before Rome was even a village. By the end of this exploration, you will see the blueprint of urban sanitation rewritten, revealing ingenious systems that modern engineers still admire. How did a city without metal pipes achieve near-universal indoor plumbing? What hidden infrastructure kept epidemics at bay for centuries? The answers lie buried in the dust of forgotten empires. What does true innovation look like when you strip away everything we assume is necessary? But what exactly makes a city a megacity in the ancient world? We are not talking about modern skyscrapers or populations in the millions. In the context of a megacity was defined by a revolutionary concentration of human life, a dense and permanent settlement of tens of thousands of people living, working, and governing themselves in one place. This scale created a new kind of problem, a logistical puzzle of unprecedented complexity. For our story, we focus on the great urban pioneers of the 3rd and 2nd millennia before the Common Era, civilizations that built their first metropolises while much of the world was still dotted with small villages. 3 legendary examples stand as our guides. From the banks of the Indus River in modern-day Pakistan, the meticulously planned city of Mohenjo-daro. In the Fertile Crescent between the Tigris and Euphrates, the towering ziggurats and bustling streets of Mesopotamian powerhouses like Ur and Babylon. And across the ocean, in the highlands of what is now Mexico, the vast, geometrically perfect city of Teotihuacan, with its massive pyramids aligned to the stars. Each of these places faced the monumental task of managing communal health centuries, and in some cases over a millennium, before the first Roman stone was laid for their famous sewers. Their solutions were not mere prototypes, they were masterpieces of civil engineering, born from necessity and a profound understanding of the urban condition. The real question is not whether they had systems, but how those systems worked so well for so long, hidden in plain sight beneath the feet of every citizen. A city's lifeblood is not its grand temples or palaces, but its water. This simple truth was the first and most sacred principle for every ancient urban planner. Before a single brick could be laid for a sewer, the fundamental question had to be answered: where will the clean water come from? The staggering achievements in sanitation we are about to uncover were not standalone miracles. They were the direct result of a more profound innovation, a completely integrated approach to urban hydrology. These builders understood that you cannot manage waste if you cannot first manage water. Their cities were not just placed near rivers by chance, they were engineered around them, with every street, every house, and every public space designed from the ground up as part of a single, living water system. Think of it as the ancient world's version of a circulatory system. A river or a reliable spring was the heart, but instead of veins and arteries, they built networks of canals, reservoirs, and carefully sloped streets that worked in harmony. Water was guided into the city for drinking, for bathing, for industry. Then, that same flowing force was used to carry away what the community no longer needed. This was not an afterthought. At Mohenjo-daro, the entire city was raised on massive mud brick platforms, a deliberate design to control flooding from the Indus River while creating the perfect gravity-fed slope for drainage. In Mesopotamia, the life-giving yet unpredictable Tigris and Euphrates demanded immense irrigation canals that doubled as transport routes and strategic barriers, with their flow meticulously regulated to serve the city's core. And at Teotihuacan, engineers harnessed the seasonal rains, channeling them through a grid of underground conduits that fed public fountains and replenished reservoirs. This holistic vision meant that sanitation was not a separate, unpleasant task to be dealt with later. It was woven into the very fabric of the city's existence from day one. The clean water supply and the waste removal system were two sides of the same coin, a continuous cycle engineered into the landscape itself. So when we marvel at an ancient toilet or a clever drain, we are only seeing the very end of a much grander design. The real genius lies in that foundational layer, the master plan that made everything else possible. The true test of this integrated water philosophy lies in the silent stones of a city abandoned for millennia. In the plains of the Indus Valley, around 2,500 years before the Common Era, the builders of Mohenjo-daro created what many archaeologists consider the world's first planned metropolis. Walking its streets, even in ruins, reveals a startling vision of order. The city was laid out in a precise grid pattern, with main avenues running north-south and east-west, dividing the urban space into neat, rectangular blocks. This was not a haphazard collection of buildings that grew organically over time. This was a blueprint executed with remarkable discipline. Every house, from the more spacious dwellings to the smaller units, was constructed from standardized, kiln-fired bricks of a uniform ratio, a consistency that speaks to a centralized authority and a shared civic ideal. The visual harmony is striking, but the real revolution was hidden from view, running literally beneath the surface of every street. Mohenjo-daro's most celebrated achievement was its comprehensive, city-wide drainage and sanitation system, a network so advanced it would not be matched in scale or sophistication for over 2,000 years. This was the physical manifestation of their water management philosophy, a subterranean labyrinth of baked clay pipes, brick-lined channels, and carefully designed outlets that connected the private space of the home to the public responsibility of the city. To understand how this civilization thrived for centuries, we must look down into the gutters and conduits that were the unseen heartbeat of urban life. The components of this system, from the humble home drain to the grand street channel, tell a story of everyday genius that turned the challenge of waste into a cornerstone of civic pride. Every house in Mohenjo-daro held a direct connection to this civic lifeline. The system began at the most private level, inside the walls of a home. Most residences, from the larger courtyard houses to more modest dwellings, contained a dedicated bathing area with a floor made of tightly fitted bricks, sloped gently toward one corner. There, a simple yet effective drain, often just a hole covered with a perforated brick, would carry wastewater away. This was not a luxury, it was a standard feature, as expected as a door or a roof. From that small opening, the water would flow out through a terracotta pipe set into the thick exterior wall, emptying into a much more substantial network waiting just outside. The genius of the design was its hierarchy, a branching tree of water management. Those clay pipes from individual homes fed into small, brick-lined gutters that ran along the sides of the neighborhood's narrow lanes. These smaller channels, in turn, merged into the city's main arteries, the grand covered drains that ran beneath the wider central streets. Walking down a main avenue, a citizen would see only a neat line of large, rectangular limestone slabs, each with a carefully cut opening. Lift one of those slabs and you would peer into the city's hidden veins, a deep channel wide enough for a person to stand in, constructed from those same standardized bricks and sealed with a gypsum-based mortar to prevent leaks. To pass beneath a street or a building, these large drains were sometimes roofed with a corbelled arch, bricks stacked in successively inward projecting layers until they met at the top, creating a sturdy tunnel that could bear the weight of the city above. Gravity did all the work. Every street, every lane, every drain was laid with a precise, calculated slope, ensuring a constant, gentle flow from the higher districts of the city down toward the riverbanks on the lower edges. But the system was not just about moving liquid away. At strategic points, especially where smaller drains met larger ones, the builders incorporated simple but effective filtration. They constructed cesspits, deep brick chambers where the flow of water would slow, allowing heavier solid matter to settle out at the bottom before the clearer liquid continued on its journey. Other pits, known as soak pits, were filled with pottery shards and sand, acting as primitive septic tanks where organic material could slowly break down. This attention to detail reveals a profound priority. The city's wealth was not poured solely into adorning palaces with gold, but into investing in this unseen, unglamorous infrastructure that served every resident. It was a silent social contract built in brick and mortar, a declaration that public health and communal cleanliness were the true foundations of a great civilization. The proof is in the remarkable lack of evidence, an absence that speaks volumes to archaeologists. For a city that thrived for centuries with a population in the tens of thousands, researchers find surprisingly few traces of widespread illness or epidemic in the remains studied. This suggests their engineered environment was not just impressive, it was profoundly effective. This network of public drains was only half the story, for it required a starting point, a private commitment from every household. The true measure of Mohenjo-daro's sanitary revolution is found not in the grand avenues, but behind the brick walls of its ordinary homes. Archaeologists have uncovered something remarkable, a level of domestic hygiene that was, for its time, almost universal. A significant majority of the excavated houses, regardless of their apparent size or status, contained dedicated, purpose-built sanitation facilities. This was not a luxury for the elite, it was a standard feature of urban living, often located on the ground floor for practical gravity-fed drainage. These rooms were thoughtfully designed. Many homes featured a simple yet effective latrine, a small chamber with a brick floor. In the corner, a terracotta pot or a chute made of fitted bricks would be set into the floor, connected directly to the underground drain running just outside in the street. Waste would be directed down this chute, exiting the private domain to be carried away by the city's flowing water. Right next to this space, frequently in the same room or an adjacent one, was a dedicated bathing area. This was more than just a corner with a bucket. The floor was carefully constructed with tightly laid bricks, sloped toward a central drain. In some of the larger residences, archaeologists have found raised bathing platforms, almost like early shower stalls, where a person could stand and pour water, with the runoff efficiently channeled away. This integration of functions, the toilet and the bath placed together with proper drainage, reveals a sophisticated understanding of personal cleanliness and waste management as linked parts of daily life. To appreciate how extraordinary this was, we must contrast it with the rest of the ancient world at the time. In contemporaneous Mesopotamia, for all its grandeur, such private facilities were exceedingly rare. Personal hygiene often relied on bathing in rivers or using portable vessels, with waste disposal being a much more manual, decentralized affair. In Egypt, while the wealthy had some drainage, it was far from a city-wide standard. The people of Mohenjo-daro lived with a convenience and a sanitary expectation that would not become commonplace again for thousands of years. Their innovation was social as much as it was technical. A shared cultural value literally built into the foundation of every home, ensuring that public health began at the most private threshold. Yet this obsession with water and cleanliness extended far beyond the private home. At the very heart of Mohenjo-daro, raised on a massive brick platform, sits a structure that embodies this civic philosophy in its most monumental form, the Great Bath. This is not a simple pool. It is a feat of engineering and a profound architectural statement. The bath itself is a large rectangular tank, roughly 39 feet long, 23 feet wide, and 8 feet deep, built with precise, finely fitted bricks. But the true mastery is in its lining, a layer of bitumen, a natural tar, carefully applied to make the entire structure watertight, an ancient precursor to modern waterproofing. A surrounding colonnade and series of rooms suggest this was a controlled, special access space, not a public swimming hole. So what was its purpose? The answer remains one of archaeology's elegant puzzles. The most compelling theory sees it as a center for ritual purification. In many ancient cultures, physical cleanliness was inextricably linked to spiritual purity. Water was not just for washing away dirt, but for symbolic renewal. The Great Bath, with its meticulously controlled, clean water, could have been the stage for important ceremonial acts, a place where the community's leaders or priests performed rites to ensure cosmic and civic order. Other scholars propose it served as a sophisticated public reservoir, a guaranteed source of clean water for the citadel's inhabitants, or perhaps an exclusive bathing facility for a privileged class. But regardless of its specific use, its message is unmistakable. The enormous investment of labor and skill to create this sealed, monumental water feature speaks to a culture that placed supreme value on the controlled, ceremonial, and communal management of water. It stands as the spiritual and physical anchor of the city's sanitation ethos. The Great Bath was not separate from the network of drains and home latrines. It was their symbolic heart. It proclaimed that water was sacred, its purity a collective responsibility, and its proper management the very definition of civilization. This cultural mindset is what made the technical systems possible, transforming engineering from a mere utility into a cornerstone of urban identity. But the Indus Valley was not alone in its struggle for urban order. Far to the west, in the fertile lands between the Tigris and Euphrates rivers, another civilization was building cities of staggering scale and ambition. In Mesopotamia, the very cradle of urban life, engineers faced a radically different set of constraints. Their primary building material was not the kiln-fired, waterproof brick of Mohenjo-daro. It was mud shaped into bricks and dried in the relentless sun. This was a practical choice, born of a landscape rich in silt but lacking in abundant timber for fuel. Sun-dried mudbrick is strong, inexpensive, and provides excellent insulation from the desert heat, but it has one critical vulnerability: water. A heavy rain or constant flow could dissolve a mudbrick wall or channel back into the earth from which it came. This fundamental limitation meant Mesopotamian architects could not simply replicate the vast, buried sewer networks of the Indus. They had to innovate in a different direction. Their sanitation philosophy became less about creating permanent, underground highways for waste, and more about clever collection, containment, and manual removal. It was a system built around the properties of their materials and the rhythms of their society. While Mohenjo-daro engineered water to flow away, Mesopotamian cities often engineered ways to safely hold waste until it could be taken away. This distinction reveals a fascinating truth. There is no single blueprint for a clean, ancient city. Different environments demanded different genius. In the land of ziggurats and epic poetry, public health was maintained not by invisible currents, but by visible, daily practice and ingenious, small-scale solutions. The most telling evidence of this approach is found not in grand civic drains, but in the humble objects of everyday life and in the architectural adaptations made within the walls of a home. To understand how a city of mud stayed clean, we must look at the tools of disposal and the pathways they created. The Mesopotamian solution flowed along its greatest lifelines, the canals. These were not mere ditches for watering fields. They were the superhighways of the civilization, arteries of commerce, transportation, and crucially, urban management. The same network that brought life-giving water from the rivers to nourish vast fields of barley and date palms also provided a ready-made pathway for a city's liquid refuse. Archaeologists suggest that organic waste, the byproducts of daily living, cooking, and crafting, was likely channeled into these flowing waterways. A household would dispose of its wastewater into a street gutter, which would feed into a smaller canal, eventually merging with the larger agricultural channels on the city's outskirts. There, the nutrient-rich water could have been used to fertilize crops in a remarkably efficient, if not entirely sanitary by modern standards, recycling loop. This practice turned a potential urban problem into an agricultural resource, integrating the city's metabolism with the farmland that sustained it. But canals could not carry everything. For solid waste and everyday debris, Mesopotamian cities developed a different strategy, one visible in the very ground they stood on. The management of public space was key. Wide processional avenues leading to temple complexes were likely kept clean through regular, organized effort, perhaps by temple staff or municipal authorities. In the warren of smaller residential streets, responsibility likely fell to individual households. Archaeologists find evidence of this in the form of rubbish pits dug within house compounds, filled with broken pottery, animal bones, and ash from hearths. Over centuries, this cycle of accumulation and renewal literally raised the city. Layers of discarded material, compacted debris, and collapsed mudbrick would be leveled over, and new structures built on top. These artificial hills, known as tells, are the iconic mounds that dot the Middle Eastern landscape, each layer a compressed archive of daily life and disposal. A tell is not just a hill, it is a monument to pragmatic urban recycling, where yesterday's refuse became the foundation for tomorrow's neighborhood. This approach required constant communal vigilance, a shared understanding that keeping the pathways clear and managing one's own waste was essential for the health of the whole. It was a system built on routine rather than hidden infrastructure, proving that a clean city could rise from the very dust it sought to manage. The Mesopotamian reliance on canals and tells points to a deeper principle at work in the ancient world, one that turned a fundamental urban challenge into an agricultural advantage. In many of these early megacities, human waste was not seen as mere refuse to be discarded, but as a valuable resource to be reclaimed. This practice, known historically as night soil, likely formed the backbone of a sophisticated circular economy. Imagine the logic of an agrarian society that understood, perhaps through generations of observation, that the fertility of their fields diminished with each harvest. They would have noticed that areas where waste accumulated often saw lusher plant growth. The solution was elegant in its simplicity: systematically collect what the city produces and return it to the land that feeds the city. This was not a casual activity. In a densely populated center, the organized collection of night soil would have required significant social coordination. It may have been a duty assigned to specific laborers, perhaps working in the cooler hours after dusk, which gave the practice its name. These collectors would transport the material beyond the city walls to vast composting pits or directly to outlying fields. There, after a period of aging to reduce pathogens, it would be carefully integrated into the soil, completing a vital nutrient cycle. The city's food supply was literally nourished by the city itself. This system transformed a potential public health crisis into a cornerstone of food security and economic stability. It represents one of humanity's earliest and most direct forms of recycling, a closed-loop system that sustained urban life for generations. The social organization behind it speaks volumes, revealing a community that viewed every output, even waste, as part of a larger, interconnected system of survival. This pragmatic wisdom ensured that nothing and no one's labor was truly wasted. Across the world and centuries later, another civilization faced the water puzzle from an entirely different angle. In the highlands of central Mexico, the builders of Teotihuacan confronted a hydrological reality defined not by abundance, but by dramatic seasonal contrast. While the Indus had its mighty river and Mesopotamia its twin life-giving flows, the Valley of Mexico presented a more temperamental partner, the sky itself. Here, water arrived in torrents during the rainy season, capable of carving gullies and flooding streets, only to retreat for months of arid stillness. To construct a permanent megacity here, home to perhaps 125,000 people at its peak, was an act of profound confidence. Their solution was not to import a river, but to master the rain, transforming a potential threat into a managed resource through an unparalleled feat of urban engineering. The entire city, from its colossal pyramids to its sprawling residential compounds, became a single, giant catchment system. Every flat roof, every paved courtyard, every wide ceremonial avenue was designed with one silent, unifying purpose: to capture, channel, and control every drop of water that fell from the heavens. This was hydraulic engineering woven into the city's bones, a system so comprehensive it dictated the very slope of the streets and the layout of the neighborhoods. The most famous of these avenues, the Street of the Dead, is more than a ceremonial path. It is the spine of this hydrological machine. Running for over 1.5 miles, this immense roadway is not perfectly flat. It was constructed with a deliberate, gentle gradient falling several meters from one end to the other. This was not an architectural mistake, it was hydraulic genius. During a downpour, the Street of the Dead would have functioned as a grand central canal, swiftly directing runoff away from the sacred precincts and the densely packed apartment complexes that flanked it. But the water was not merely expelled, it was guided. Beneath the stone-paved surface and along the edges of the avenue, archaeologists have uncovered a complex network of subterranean conduits, carefully lined with stone and waterproofed with clay. These were not sewers for waste in the traditional sense, but storm drains on a monumental scale, designed to handle the immense surge of seasonal water and funnel it to where it was needed most. The system collected this precious resource into massive, strategically placed reservoirs and cisterns, storing it for the long dry season to supply the city's fountains, irrigate its gardens, and sustain its population. In Teotihuacan, the sky was the river, and the entire urban landscape was the aqueduct. The sheer scale of Teotihuacan's water mastery becomes tangible at its ceremonial core, the Ciudadela. This immense sunken plaza, surrounded by temple platforms, was not just a sacred space, it was a hydraulic engine. Its entire floor, a vast expanse of precisely fitted stone, was laid with a deliberate, almost imperceptible slope. During the rainy season, this design transformed the plaza into a colossal funnel. Water from the surrounding structures and the open sky would rush across the smooth stone, converging toward the center where a monumental drain awaited. This was no simple outlet but a deep, stone-lined channel, a subterranean river designed to swallow the torrential flow and direct it away from the complex's foundations. The engineering prevented the sacred precinct from becoming a muddy lake, protecting the architecture from water damage and ensuring the plaza remained a functional, dry stage for rituals the moment the rain ceased. This same principle of controlled runoff defined the experience of moving through the city itself. Along the Great Street of the Dead and other major avenues, the walkways for citizens were raised. Running beneath them, hidden from daily view, were deep drainage canals meticulously constructed with stone slabs and waterproof mortar. These were the city's arteries for stormwater. A downpour would see these channels come alive, carrying the flood from the paved surfaces and rooftops on a swift, predetermined journey out of the residential districts. This constant flow served a crucial sanitary function. It would have swept away daily debris and organic matter left in the streets, naturally cleansing the public thoroughfares. More importantly, by swiftly removing vast quantities of water, the system prevented the pooling and stagnation that breeds illness. It kept the foundations of thousands of apartment compounds dry and stable, a fundamental requirement for the city's enduring physical health. In Teotihuacan, every rainfall triggered a city-wide flushing mechanism, an elegant, gravity-powered solution that turned a climatic challenge into a tool for urban hygiene. The grand avenues and ceremonial drains of Teotihuacan were only the beginning of the story. For this water-centric philosophy to truly work, it had to extend into every home, into the daily rhythms of its citizens. Within the city's massive residential compounds, where extended families and craft specialists lived in interconnected apartments, archaeologists find the same meticulous attention to hydraulic detail, just on a more intimate scale. These were not simple huts, but multi-room complexes built around central courtyards, and nearly everyone was engineered to manage water from roof to street. The system started at the top, where flat roofs captured the precious rainwater. This water was then channeled through carefully placed clay pipes set within the thick masonry walls, directing the flow down into the courtyard below. There, in many compounds, you would find a sunken basin or a cistern, a private reservoir where a household could store its own water supply for the dry months. But the water's journey did not end there. The courtyards themselves were paved with stone or hard-packed earth, sloped gently toward strategically placed drains. These were not just holes in the ground. They were often sophisticated fittings made of carved stone or ceramic, designed to connect to a network of small underground conduits that ran beneath the living quarters. These household channels, lined with waterproof clay, would then merge and exit the compound, emptying directly into the larger street-side drains that fed the city's monumental system. This created a perfect hydraulic hierarchy, a cascade of control from the private roof to the shared courtyard to the public street, and finally into the grand civic arteries. Every drop was accounted for, and every residence was an active participant in the city's circulatory system. The most telling evidence of this domestic commitment to sanitation, however, lies in a small, often overlooked feature: the household latrine. In several of the more elaborate apartment compounds, archaeologists have identified small, dedicated rooms with a key detail: a floored drain connected to the same underground ceramic piping. The placement suggests these were not just washrooms, but possibly early forms of water-assisted latrines. A resident could have used stored rainwater or water brought from a courtyard cistern to rinse waste through the drain, leveraging the same gravity-fed principles that govern the entire city. This practice would have confined waste to a controlled, drainable location, a significant advancement in household hygiene that prevented contamination of living spaces. It shows that the people of Teotihuacan understood sanitation as a two-part process: the majestic, city-wide management of stormwater to prevent flooding and stagnation, and the careful, private management of human waste to prevent illness at its source. The monumental drains were the city's immune system, handling external threats like torrential rain. The domestic drains and latrines were its daily digestive system, managing the internal byproducts of urban life. One could not function without the other, and together they formed a complete, resilient philosophy of urban health, built one clay pipe and one stone courtyard at a time. The planners of Teotihuacan did not just adapt to their landscape, they reshaped it with breathtaking ambition. A single, startling fact reveals the scale of their vision: the San Juan River, a natural waterway that once flowed through the valley, does not run through the ancient city as we find it today. Instead, its course was deliberately altered, moved by human hands to align perfectly with the city's rigid geometric grid. This was not a minor landscaping project. It was a wholesale re-engineering of the local hydrology. For a civilization without modern machinery, the labor involved was staggering, requiring the movement of untold tons of earth and stone to divert a river's entire path. Why would they undertake such a monumental task? The answer lies in their uncompromising desire for order and control. A meandering, natural river is a capricious force, prone to unpredictable flooding during the rainy season and shrinking to a trickle in the dry months. Its banks shift, its currents change, and it carves its own path with little regard for the streets and buildings of a meticulously planned metropolis. For the master architects of Teotihuacan, such unpredictability was unacceptable. Their city was a cosmic diagram in stone, a reflection of celestial order on earth. A wild river cutting across their sacred geometry would have been more than an inconvenience. It would have been a flaw in the very fabric of their design. By rerouting the San Juan, they tamed a force of nature, turning it from a potential agent of chaos into a predictable, integrated component of their urban machine. The river's new, straightened channel became the ultimate engineered watercourse, a permanent, reliable artery that served multiple, vital functions. First and foremost, it was a masterstroke of flood control. The canalized river, with its reinforced banks and controlled flow, could handle the surge of seasonal rains without overflowing into the city's residential compounds or undermining the foundations of its pyramids. This single act protected their immense investment in architecture and safeguarded the lives of tens of thousands, but the benefits flowed far beyond simple protection. This new, artificial riverbed became the backbone for a managed water network. From its main channel, secondary canals could be dug with precision, branching off at right angles to feed irrigation ditches for the vast agricultural fields that fed the city. It provided a steady source of water for the city's reservoirs and public fountains during the dry season. Perhaps most ingeniously, it offered a ready-made transport route. Heavy materials like building stone, timber, and agricultural goods could be moved by barge or raft along this liquid highway, integrating the city's economy with its hinterlands. And from a sanitation perspective, this controlled flow offered a constant directional current. Wastewater from the city's drainage systems could be channeled into this managed river, where it would be swiftly carried away from populated areas, preventing stagnation and the spread of illness. The rerouting of the San Juan River stands as one of the most audacious acts of urban planning in the ancient world. It demonstrates a profound truth about these early megacities. Their survival and prosperity were not gifts of geography, but victories of will and intellect. They looked at the world not as it was, but as it could be, and they moved rivers to make it so. Three distinct blueprints for urban survival emerge from the dust of these ancient worlds. The Indus Valley civilization crafted a model of comprehensive, integrated hygiene, a system built to last. Their cities were founded on the principle of universal access, with baked brick pipes and covered drains connecting nearly every home to a city-wide network. This was a democratic vision of public health, engineered into the very fabric of daily life. Their use of durable, waterproof materials reflected a long-term commitment, an infrastructure designed for permanence and ease. Water and waste moved in a continuous, hidden flow, managed by gravity and clever filtration, creating a remarkably clean and orderly urban environment. It was a technical solution of remarkable foresight, prioritizing prevention and convenience for all citizens. In stark contrast, the Mesopotamian approach was one of brilliant adaptation to limitation. Bound by their primary building material, sun-dried mudbrick, they could not construct vast underground sewers. Instead, they turned to their greatest artificial feature, the life-giving canal. Liquid waste found its path into these flowing waterways, while solid refuse was managed through localized disposal in household pits and the gradual, deliberate raising of the city itself into tells. Their system was less about hidden pipes and more about visible cycles, the pragmatic reuse of night soil to fertilize fields, turning a sanitary challenge into an agricultural resource. This was a solution built on routine, social organization, and a circular economy, proving that a clean city could thrive even without the most advanced permanent infrastructure. Finally, Teotihuacan presented a masterclass in hydrological ambition. In a land without a reliable river, they engineered the entire city as a monumental rain-catching machine. Every roof, courtyard, and street was sloped and channeled to capture, control, and store seasonal downpours. Their sanitation was a byproduct of flood control, with massive storm drains and rerouted rivers carrying away water and debris in a powerful seasonal flush. Their priority was architectural integration, weaving water management into the cosmic order of their cityscape, from the grand street of the dead down to the clay pipes in a family compound. Here, sanitation was inseparable from urban design and spiritual geography. These comparisons reveal a profound truth. There was no single path to a healthy ancient megacity. Each civilization responded to a unique combination of environment, material, and cultural priority. The Indus had durable brick and a philosophy of universal, private convenience. Mesopotamia had fertile silt and a pragmatic focus on reuse and agricultural integration. Teotihuacan had seasonal torrents and a monumental vision of controlling the very sky. Their solutions were as different as their landscapes, yet all achieved the same extraordinary result, sustaining dense urban life for centuries against the relentless tide of waste and water. This diversity of genius suggests that the heart of ancient urban success was not a specific technology, but a shared mindset, an unwavering commitment to solving the fundamental puzzle of living together. The ultimate test of any sanitation system is not its elegance but its results. Did these ancient networks of brick and water truly protect the people they were built to serve? While we cannot interview a citizen of Mohenjo-daro about their health, the silent testimony of the ground they walked on offers compelling clues. Archaeologists studying the physical remains of these well-planned cities note a remarkable absence, a lack of evidence for the kind of catastrophic, widespread epidemics that would later ravage dense urban centers in other eras. This is not to say these were paradises free from illness. Life in antiquity was challenging, and individuals certainly faced health hardships. Yet the archaeological record, from burial sites to household refuse, does not show the sudden, mass casualties or the cultural disruptions that typically accompany unchecked plague. The bones tell a story of communities that, for centuries, managed to avoid the worst ravages of communal disease. This stands in stark contrast to the grim realities of many later medieval European cities, where populations packed into cramped, unplanned warrens with minimal waste management. In those settings, illnesses like cholera and dysentery, born from contaminated water and filth, could sweep through a population with terrifying speed, claiming lives by the thousands in recurring cycles of suffering. The ancient megacities, by design, seem to have broken that cycle before it could even begin. This success likely hinged on a simple, powerful principle: separation. Their infrastructure created a physical barrier between the sources of illness and the daily lives of citizens. By providing a dedicated, flowing channel for wastewater, they prevented human waste from contaminating the drinking water supply. This single engineering achievement would have drastically reduced the incidence of deadly waterborne diseases. A community that drinks from a clean well, separate from where its waste flows, is a community that sidesteps one of history's most persistent killers. Furthermore, the constant movement of water in street drains and the careful slope of courtyards prevented the dangerous pooling and stagnation where disease-carrying insects breed. The systems were not perfect by any modern medical standard, but they were profoundly effective within the knowledge of their time. They managed the environment to minimize the vectors of transmission, creating a baseline of public health that allowed these complex societies to flourish generation after generation. We must, of course, acknowledge the limits of what archaeology can prove. Soft tissue decays, and many illnesses leave no mark on bone. The absence of evidence is not absolute proof of an absence of disease. Yet, when we pair this quiet archaeological record with the sheer ambition of the infrastructure we find, a logical and powerful connection emerges. These civilizations invested an enormous portion of their collective labor and ingenuity into building these systems. They would not have done so if the benefits were not glaringly obvious to them. The clean streets, the fresh water, the absence of foul odors, the overall vitality of their population, these were the daily rewards of their engineering. Their legacy is not found in a single medical text, but in the enduring stability of their urban experiment. They demonstrated through brick and gradient that a city did not have to be a death trap. It could be a sanctuary of order where the fundamental challenge of living together was met not with resignation, but with brilliant, flowing solutions. This realization shifts our entire perspective on antiquity, revealing a pragmatic wisdom that prioritized the health of the community as the true foundation of power and longevity. These flowing networks of brick and water could not maintain themselves. A drain, no matter how perfectly engineered, is only as effective as the society that cares for it. The silent, functioning order of these cities points to a powerful, unseen force, a sophisticated level of social organization that turned blueprints into lived reality. Building a city-wide sewer required thousands of laborers working in concert, but keeping it clear for centuries required something even more complex: a shared civic contract and a system of authority to uphold it. This was the true overhead of cleanliness, the daily, unglamorous work of administration that transformed engineering into enduring public health. We must move from the physics of water flow to the sociology of collective action. Who decided where the main drain would run? Who had the authority to tell a homeowner they could not build over a public channel? And when a crucial pipe beneath a busy street became clogged with debris, whose responsibility was it to lift the heavy stone slab and clear the blockage? The answers reveal these megacities as pioneers of municipal government long before the concept had a name. The initial construction alone implies a central authority with remarkable power. At Mohenjo-daro, the uniformity of the bricks, the precise grid of the streets, and the consistent placement of drainage channels across the entire city are not the hallmarks of a neighborhood building committee. This speaks to a strong, likely theocratic or oligarchic leadership capable of planning on a grand scale and mobilizing the population to achieve it. This authority would have controlled crucial resources, like the fuel for kilns to fire millions of bricks, and directed specialized labor, from surveyors calculating the vital street gradients to masons sealing pipes with waterproof mortar. It was a top-down vision executed with remarkable discipline. Similarly, the rerouting of the San Juan River at Teotihuacan was an act that would have been impossible without a commanding central power, one that could conscript and organize labor on a staggering scale for a project that benefited the entire polity, not just a single neighborhood. This suggests that the very concept of public works, of infrastructure that served the common good, was born from the necessity of urban survival and required a powerful entity to champion it. Yet construction is a single event, maintenance is forever. The long-term operation of these systems required a different kind of organization, one that permeated daily life. Here, we likely see a blend of centralized oversight and decentralized communal responsibility. A priestly class, often the custodians of cosmic and natural order, would have had a profound interest in upholding the purity of water, linking practical cleanliness to spiritual law. Royal decrees or civic codes may have established rules forbidding the dumping of certain wastes into street drains or mandating that households keep their section of the gutter clear. Enforcement might have fallen to a class of inspectors or overseers, perhaps answerable to the temple or palace. But much of the daily upkeep would have relied on a shared understanding, a cultural norm so ingrained it felt like common sense. Just as a modern homeowner shovels the public sidewalk in front of their house, an Indus Valley family likely felt responsible for ensuring the drain from their home did not back up and affect their neighbors. Blockages at major intersections, however, would have required coordinated municipal labor, a public works crew funded by communal tithes or taxes. This intricate dance between authority and community is what sustained the system. It was a social technology as vital as the clay pipes themselves, a framework of rules and roles that ensured the city's invisible veins continued to pulse. This organizational model represents a fundamental shift in human society, the birth of the municipality. For the first time, groups of people were not just bound by kinship or trade, but by a shared dependency on a man-made environment. Their collective health and prosperity hinged on shared infrastructure, which in turn required shared rules and shared contribution. The authority that managed the water was, in essence, an early form of city government. Its legitimacy derived from its ability to provide this critical service. It managed conflict, allocated resources for repairs, and standardized practices across diverse neighborhoods. This was governance born not from conquest alone, but from the pragmatic need to manage the delicate ecology of 1,000 people living on top of one another. The quiet, flowing success of their streets is a testament to their success in this endeavor. They mastered not only the engineering of water, but the harder engineering of human cooperation, building a social order where cleanliness was not just a personal virtue, but a public trust. The true monument they left behind was not the pyramid or the bath, but the invisible, enduring agreement to keep the water flowing for everyone. The silent agreement to keep a city clean ran deeper than any civic code. This commitment was not born from fear of illness alone, but was often woven into the very fabric of belief, reinforced by stories of the gods themselves. For these ancient societies, sanitation was rarely a purely practical matter. It was a sacred duty, a physical act with spiritual consequences. The distinction between being clean and being pure was often invisible, and this fusion of the practical and the divine provided a powerful, enduring motivation for maintaining the systems that kept the city alive. We can see this sacred dimension clearly across all three of our case studies. In Mesopotamia, surviving texts and law codes reveal a world where ritual purity was paramount. Certain activities, like approaching a temple or participating in a ceremony, required specific acts of washing and cleansing. This was not just about removing dirt, but about preparing the individual to interact with the divine realm. A person who was physically unclean might also be considered spiritually unfit. These beliefs, encoded in tradition and sometimes in law, created a cultural imperative for personal hygiene that supported public health. It meant that keeping oneself clean was an act of piety, a way to honor the gods and maintain one's place in the ordered universe. The daily practice of washing, then, was reinforced by a powerful celestial incentive. Meanwhile, in the Indus Valley, the monumental Great Bath stands as a silent testament to what archaeologists often call a cult of water. While we lack their written texts, the architecture shouts their reverence. The immense effort to create a perfectly sealed, monumental pool of clean water in the heart of their citadel suggests water held a profound symbolic value beyond the mundane. It was likely a stage for rituals of purification and renewal, where the leadership performed acts that ensured both spiritual and civic order for the entire community. In this context, the network of household drains and street channels was more than just plumbing. It was the practical extension of a sacred principle. Keeping the city's water clean, from the Great Bath down to the smallest gutter, was an act of collective worship, a way to uphold the cosmic harmony that their carefully planned city reflected. This cultural mindset transformed maintenance from a chore into a communal ritual, and in the highlands of Mesoamerica, the sacred geography of Teotihuacan reveals a cosmology built around water. Their gods were intimately linked with rain, fertility, and the life-giving forces of the storm. The city itself, with its grand avenue named the Street of the Dead and its pyramids aligned with celestial bodies, was a map of the cosmos. By engineering the entire urban landscape to capture and control rainwater, they were performing a continuous act of communion with these deities. They were not just managing a resource, they were participating in a divine cycle, channeling the essence of the rain gods into their reservoirs and through their ceremonial drains. A clogged channel or a neglected courtyard drain was not merely a technical failure. It could be seen as a disruption of this sacred flow, an offense to the very forces that sustained life. This belief system provided a powerful, top-down motivation for the immense labor of rerouting rivers and maintaining miles of underground conduits. The spiritual stakes made the technical imperative non-negotiable. When we view these ancient systems through this lens, their resilience makes profound sense. A law can be ignored, a practical benefit can be forgotten in a generation. But a belief that ties cleanliness to the favor of the gods, to the very order of the cosmos, becomes ingrained in the culture's soul. It provides a story, a meaning that outlasts kings and dynasties. The daily act of using a household drain or clearing a street gutter became a small, personal contribution to upholding a sacred balance. This fusion of faith and function created a self-reinforcing cycle, where religious practice supported public health, and the visible success of a clean, thriving city reinforced the power of the beliefs that sustained it. The stones of their sewers were held together by more than mortar. They were bonded by a shared story about the nature of purity, community, and humanity's place in a living, fluid world. Yet even the most brilliant engineering has its breaking point. For all their foresight, the master builders of the ancient world were still contending with forces far beyond their control. Their systems, while revolutionary, operated within a fragile balance, vulnerable to the very nature they sought to master. The first and most relentless threat was the water they depended on. In the Indus Valley, the same river that gave life could also take it away. Evidence suggests that Mohenjo-daro suffered catastrophic flooding on multiple occasions. A single, massive flood surge could overwhelm the carefully calculated gradients of the street drains, filling the brick-lined channels with silt and debris. Once clogged, the entire network would back up, turning orderly streets into stagnant ponds and rendering household drains useless. The repair effort after such an event would have been immense, requiring the coordinated labor of thousands to dig out miles of submerged conduits. Similarly, in Mesopotamia, the intricate network of canals was perpetually at war with silt. The very fertility of the land came from the fine sediment carried by the Tigris and Euphrates, and this same silt would steadily accumulate in the irrigation and drainage channels. Without constant, organized dredging, the canals would slowly choke, reducing their flow and their capacity to carry away waste. This created a vicious cycle of maintenance, a battle against the landscape that required unwavering social cohesion and resource allocation just to maintain the status quo. A prolonged period of political instability or a shift in priorities could mean the difference between a flowing canal and a fetid ditch. And in Teotihuacan, the masterful storm drains faced their own paradox. A period of extended drought could see the channels sit dry for years, allowing debris and soil to blow in and accumulate. Then, when the long-awaited rains finally arrived, the first torrents would not flow smoothly to the reservoirs, but would instead hit these blockages, causing localized flooding and erosion that could undermine the foundations of the very structures the system was built to protect. Their brilliance lay in managing the predictable cycle, but nature is rarely so courteous as to remain predictable forever. Beyond the grand disasters of flood and silt, daily life within these cities would have presented a more mundane, persistent challenge. The romantic image of a perfectly odorless, pest-free ancient metropolis is just that, a romantic image. While their systems drastically reduced the sources of contamination, they could not eliminate them entirely. The street drains, especially the smaller ones in residential lanes, would have required regular clearing of everyday refuse, from food scraps to broken pottery. If a household grew negligent, or if a section of the city fell on harder times, blockages would occur. These stagnant pockets of organic matter would inevitably produce odors and attract insects and rodents. The use of cesspits, while clever, meant that solid waste was still collected and stored within the city limits, at least temporarily. The process of emptying these pits for use as fertilizer, while practical, would have been a distinctly unpleasant task, and one that surely left its mark on the air of a neighborhood. Furthermore, the very design of some systems could create issues. In Mohenjo-daro, the covered main drains, while elegant, would have been dark, confined spaces, difficult to access and clean thoroughly without dismantling the street above. Over time, layers of sludge would build up on the brick walls, narrowing the channel and reducing its efficiency. The battle against decay and entropy was constant, a silent war waged by an army of unnamed laborers with buckets and shovels, fighting to keep the city's hidden veins open. The true marvel is not that these systems were perfect, but that they worked as well as they did for as long as they did, holding the messy reality of urban life at bay through sheer, sustained effort. The ultimate testament to these limitations is written in the final chapters of these cities' stories. The decline of a megacity is never simple, often a slow unraveling from a combination of pressures, climate shifts, political fragmentation, or economic collapse. But in almost every case, the failure of the sanitary infrastructure was both a symptom and an accelerator of this decay. Imagine a scenario where the central authority in Mohenjo-daro weakens. The specialized crews responsible for dredging the main drains are no longer funded or organized. One season, a major drain clogs and is not cleared. The next flood season, the backup is worse, flooding a district and ruining homes. People begin to move away from the affected area, their taxes or labor no longer contributing to the upkeep. The problem spreads district by district as the network fractures. What was once a unified circulatory system becomes a series of isolated, failing segments. In Mesopotamia, a change in the course of a river or a prolonged drought could render the entire canal-based system obsolete. If the water does not flow, the waste cannot be carried away. The pragmatic recycling of night soil might break down if agricultural fields are abandoned, leaving waste with nowhere to go but the streets or abandoned lots. At Teotihuacan, a prolonged mega-drought would have been a catastrophic blow. The vast reservoirs would sit empty, the public fountains would run dry, and the seasonal flushing action of the storm drains would cease. Without water to carry it away, waste would accumulate, and the carefully engineered slopes of the streets would become mere architectural features rather than functioning parts of a hydraulic machine. In each case, the neglect of the sanitary system would have led to a rapid decline in urban health. The very density that made these cities great would become their curse, as stagnant water, accumulating refuse, and the pests they attracted created a breeding ground for illness. The social contract of shared maintenance would shatter, replaced by a desperate focus on individual survival. The gleaming, orderly city would slowly succumb to the disorder it had held back for centuries. This is perhaps the most poignant lesson from their legacy. Their greatest achievements were not static monuments, but dynamic, living systems. They required not just brilliant minds to design them, but a stable, committed society to nurture them. When that commitment faded, the stones remained, but the flow, the life, the very purpose of the design vanished. The silent, clogged drains became the tombs of the philosophy that built them, a final reminder that no city, no matter how well planned, is stronger than the collective will that sustains it. While the great river valley civilizations were perfecting their grand networks, a different kind of genius was emerging on an island in the sun-drenched Mediterranean. On the island of Crete, the Minoan civilization flourished from around 2000 to 1500 years before the Common Era, building not vast, grid-planned metropolises, but breathtakingly complex multi-story palaces that were, in effect, small, self-contained cities. The Palace of Knossos, with its legendary labyrinth, stands as their crowning achievement, but beyond the vibrant frescoes and storied myths, the Minoans left behind a legacy of astonishingly modern convenience, a testament to their mastery of water that rivals even the Indus Valley in its sophistication. Here, in the heart of Bronze Age Europe, we find a civilization that brought the principles of advanced sanitation into the very heart of royal and religious life, creating a system of palace plumbing that feels startlingly familiar. The innovation began with the basics of moving water. Minoan engineers crafted extensive networks of terracotta pipes, but their design was uniquely clever. These were not simple cylindrical tubes. Many were tapered, shaped like long, slender cones that fit snugly into one another. This conical design served a brilliant purpose. It created a tighter, more secure seal at each joint, minimizing leaks and increasing the water pressure within the system. These pipes snaked through the palace walls and under its floors, channeling fresh water from springs and cisterns to rooms throughout the complex. But bringing water in was only half the equation. The Minoans understood the necessity of getting it out, and they engineered an equally impressive drainage system to handle wastewater and the intense seasonal rains of the Cretan climate. Beneath the palace floors, a hidden world of stone-lined channels and more of those distinctive terracotta pipes carried used water away from bathrooms, kitchens, and workshops, directing it safely out of the living quarters. The most remarkable application of this technology, however, was in the royal apartments. In the Queen's Megaron at Knossos, archaeologists uncovered a feature that seems to leap across millennia: a flush toilet. This was no simple hole in the ground. It was a wooden seat, likely mounted over a clay bowl, connected directly to the palace's main drainage system via a sophisticated network of underground terracotta pipes. A servant would have poured water from a jug into a small conduit beside the seat, manually creating a flushing action that would carry waste through the pipes and out of the palace. Just a few steps away, in an adjoining chamber, was a beautifully appointed alabaster bathtub, also connected to the same drainage network. This intimate pairing of advanced sanitation and luxurious bathing within the private royal suite reveals a culture that valued comfort, privacy, and cleanliness at the highest levels of society. It was a level of domestic engineering that would not be seen again in Europe for over 3,000 years. This hydraulic mastery extended to the entire palace grounds, showcasing a holistic approach to water management. The Minoans were expert stormwater engineers. The vast, paved central courts of their palaces were not flat. They were subtly sloped to direct rainwater into runnels and channels that fed into a comprehensive underground drainage system. Light wells and open courtyards were designed not just for air and light, but to channel rainfall efficiently. They built extensive cisterns to store this precious rainwater for the dry season, ensuring a reliable supply. Every element of the palace's design, from the grandest courtyard to the smallest pipe, participated in a continuous, managed water cycle. The Minoan system, while concentrated in palatial centers rather than spread across a massive gridded city, represents a parallel pinnacle of ancient sanitary thought. It proves that the drive to conquer the challenges of water and waste was not confined to the river valleys of Asia or the highlands of the Americas. It was a universal hallmark of advanced urban culture, emerging independently wherever people gathered in complex societies. The quiet hum of water through clay pipes in the walls of Knossos was a Bronze Age symphony of civil engineering, a sophisticated Mediterranean echo of the same great idea that a truly advanced society is measured by what it hides beneath its feet. The sophistication of the Minoan flush toilet and the Indus Valley city-wide drains forces a profound re-evaluation of history's timeline. For centuries, the narrative of urban progress pointed decisively to Rome, with its soaring aqueducts and vast public latrines, as the undeniable pinnacle of ancient sanitation. This view, however, overlooks a crucial distinction between invention and implementation. The Roman achievement was one of breathtaking scale and imperial ambition, but the fundamental ideas that made it possible were not born on the banks of the Tiber. They were inherited, either directly through cultural contact or independently rediscovered, from civilizations that had already solved the core puzzle millennia earlier. When we place Roman engineering in this deeper context, a new story emerges, not of primal invention, but of brilliant adaptation and monumental amplification. Consider the basic components of Roman sanitation. The city of Rome itself was crisscrossed by the Cloaca Maxima, the Great Sewer, a covered stone drain that channeled waste and stormwater into the Tiber River. This was an engineering marvel of its time, a testament to Roman organizational power. Yet the concept of a large, covered civic drain designed to carry waste away from a city center was not new. The master builders of Mohenjo-daro had constructed an entire network of such covered channels over 2,000 years prior. The Romans scaled the idea to fit a metropolis of 1 million people, building it in stone instead of brick, but the underlying principle of using gravity and a dedicated underground conduit was a pre-existing solution. Similarly, Roman aqueducts are rightfully celebrated as iconic masterworks, bringing fresh water from distant sources into the heart of the city with staggering precision. But the foundational philosophy of importing clean water via engineered channels was the very lifeblood of Mesopotamian and Teotihuacan civilization. The Romans perfected the arch and the gradient on a staggering scale, but the goal of separating clean water supply from waste outflow was an ancient ideal they shared with every successful megacity before them. Even the social institutions of Roman hygiene have echoes in the past. The magnificent public baths, the thermae, were centers of daily life, combining cleanliness with socializing and business. These complexes required enormous amounts of water, delivered by aqueducts and drained by sophisticated sewers. Yet the notion of communal bathing as a civic and ritual act was vividly present in the Great Bath of Mohenjo-daro and woven into the spiritual fabric of Mesopotamian purity laws. The Romans monumentalized it, turning it into a massive, marble-clad social engine, but the cultural link between public water, communal health, and social order was a very old concept. Their famous public latrines, with rows of seats over a flowing channel of water, provided a shared sanitary facility for many citizens. This, too, was a scaling up of a basic idea. While not identical to the private household latrines of the Indus Valley or the palace plumbing of the Minoans, it addressed the same need with a characteristically Roman focus on public, communal infrastructure for the masses. So where does genuine Roman innovation lie? It is found not in the idea of urban sanitation, but in the execution. Their genius was one of standardization and replication across an empire. From the misty hills of Britannia to the deserts of Syria, Roman engineers applied a consistent template: aqueducts, baths, sewers, and public latrines as a signature of Roman urban life. This was sanitation as a tool of empire, a civilizing marker that turned any conquered town into a recognizable piece of the Roman world. They also pushed materials and hydraulics to new limits, mastering the use of lead pipes, complex siphon systems, and waterproof concrete to create more pressurized and reliable water networks. Their innovation was in the monumentalization of these systems, in the political will to deploy them across continents, and in the organizational bureaucracy needed to maintain them. They took the foundational concepts pioneered by others and built them into the largest, most integrated utility network the ancient world had ever seen. This reframing does not diminish Rome's glory, it deepens our understanding of human progress. It reveals sanitation not as a single, linear discovery, but as a recurring hallmark of complex society. When a culture reaches a certain density and ambition, it inevitably confronts the same physical laws and biological realities. The need to manage water and waste becomes a non-negotiable imperative, and brilliant minds, whether in the Indus Valley, on Crete, or in Italy, arrive at similar solutions. Rome stands as the ultimate synthesizer and amplifier of this ancient wisdom, proving that the greatest advances often come not from inventing the wheel, but from building the road that allows it to roll across the known world. Their legacy is a testament to the power of scale, organization, and the relentless drive to impose order on the chaos of urban life, a drive they shared with every great city that came before them. These silent, buried systems speak a language of their own, one deciphered not from scrolls but from soil and stone. For archaeologists, the quest to understand ancient sanitation is a meticulous process of listening to what the ground has preserved. The most direct evidence comes from the physical infrastructure itself, the tangible remains of a civilization's battle against decay. When excavators uncover a line of fitted bricks running beneath a street, or a carefully placed terracotta pipe emerging from a wall, they are not just finding artifacts, they are reading a blueprint for public health. The size, slope, and construction quality of a drain tell a story of engineering priorities. A wide, stone-lined channel beneath a main avenue points to a society investing heavily in communal infrastructure, capable of organizing labor for projects that served everyone. A small clay pipe leading from a modest home to that main channel reveals something equally profound, a standard of living extended across social strata. Finding a dedicated room with a floor drain and a chute in a house at Mohenjo-daro is not merely noting an architectural feature, it is documenting a cultural expectation, a shared value of domestic hygiene woven into the fabric of daily life. These physical networks map a society's logic, showing how they moved the unseen but essential currents of urban existence from the private sphere into a managed public domain. Beyond the visible bricks and pipes, subtler clues lie in the very chemistry of the earth. Modern archaeologists employ techniques like soil micromorphology and phosphate analysis to read landscapes invisible to the naked eye. When organic matter, such as food waste or human waste, decomposes, it leaves behind chemical signatures, particularly phosphates, that bind to soil particles and persist for millennia. By taking core samples from different areas of an ancient site, scientists can create a chemical map of past activity. A startlingly high concentration of phosphates in a sunken pit within a house compound signals a former cesspit or waste disposal area. A consistent trail of such deposits leading from residential zones toward the outskirts of a city might trace the path of waste collection routes or the location of ancient midden heaps. Conversely, the absence of these signatures in a central reservoir or a covered aqueduct channel confirms the success of their separation principles, proving they kept contaminated water away from clean sources. This forensic approach allows researchers to see the ghostly imprint of daily routines, turning empty plots of land into archives of ancient household management and civic planning. It confirms what the architecture suggests, revealing the practical footprint of a society's sanitation habits. Perhaps the most telling evidence requires stepping back, far back, to view the city as a whole. The study of urban layout or site planning offers a macro-scale view of sanitary intelligence. The deliberate grid of Mohenjo-daro was not an aesthetic choice, it was a hydraulic one. Straight, wide main streets established the primary slopes for drainage, while the smaller lanes created a hierarchical network to feed into them. The entire city was essentially a tilted plain engineered for flow. At Teotihuacan, the monumental rerouting of the San Juan River and the precise gradient of the Street of the Dead were decisions that shaped the health of the entire metropolis for centuries. By analyzing these grand designs, archaeologists understand that sanitation was not an afterthought plugged into a pre-existing city. It was a foundational parameter, a core constraint that dictated where streets would go, how neighborhoods would be oriented, and where the most important buildings would rise. This level of integrated planning speaks to a sophisticated, centralized authority capable of long-term vision. It reveals a society that understood the existential link between spatial order and communal survival. The clean lines of a city map, therefore, are not just lines, they are the physical manifestation of a social contract, an agreement to live in a way that protects the collective well-being. Interpreting this often invisible infrastructure provides a uniquely intimate window into ancient life, far beyond kings and battles. A well-maintained, city-wide sewer system implies a remarkable degree of social cohesion and administrative continuity. It tells us that for generations, people agreed to contribute labor or taxes, to follow rules about waste disposal, and to trust their neighbors to do the same. It hints at a shared identity built not just on common gods or a common enemy, but on a common interest in a clean, functioning home. The evidence of sanitation cuts across hierarchies. While the Minoan queen had her flush toilet, the ordinary citizen of the Indus Valley had a connected drain, a democratization of convenience that speaks volumes about civic priorities. Furthermore, the resilience of these systems over centuries, as shown in the archaeological layers, testifies to a deep-seated cultural adaptability. They were maintained through floods, through political changes, through the slow creep of silt, because the community understood their non-negotiable value. When these systems finally fail in the archaeological record, their collapse is a silent alarm bell, signaling a breakdown in that social order, a fragmentation of the collective will that sustained the city itself. In the end, the humble drain is one of history's most honest witnesses. It does not boast of conquests or flatter rulers. It simply records whether a society was organized enough, far-sighted enough, and cooperative enough to care for its people in the most fundamental way. The quiet proof is not in a grand inscription, but in the empty, downward slope of a stone channel, still waiting for the water to flow. The quiet genius of those ancient sewers speaks directly to our own crowded, concrete world. For all our technological marvels, the modern metropolis often operates on a startlingly primitive principle, a linear model of consumption. We take resources from afar, make products, use them briefly, and then dispose of the waste, often shipping it out of sight and mind. This one-way street of materials creates immense vulnerabilities, from overflowing landfills to strained water treatment plants, and the constant threat of supply chain disruption. The ancient megacities we have explored operated on a radically different logic, one that modern sustainability experts now call a circular economy. They viewed waste not as an endpoint, but as the starting point for another cycle. The most vivid example is the widespread use of night soil, the deliberate collection of human waste to fertilize the agricultural fields that fed the city. This was not a desperate act, but a sophisticated form of nutrient recycling. It closed the loop between urban consumption and rural production, turning a sanitation challenge into a cornerstone of food security. The city's output literally nourished its own input, creating a resilient, localized system that reduced dependency on distant sources. This circular thinking extended to water itself. At Teotihuacan, every raindrop was a resource to be captured, channeled, stored, and reused. In the Indus Valley, wastewater was filtered and directed to manage its impact. Water was kept in motion and in use for as long as possible within the urban ecosystem, rather than being quickly flushed away as a nuisance. These approaches reveal a fundamental integration that our modern, compartmentalized cities have often lost. We have brilliant systems for delivering clean water and others for processing waste, but they are frequently separate, energy-intensive silos, not parts of a unified, flowing whole. The ancient lesson is not that we should copy their specific technologies, but that we should reclaim their holistic philosophy. What if we designed modern neighborhoods to capture and treat their own rainwater, reducing the burden on massive municipal systems and replenishing local aquifers? What if organic waste from our cities was systematically composted and returned to revitalize nearby green spaces and community gardens, rebuilding soil health and reducing landfill mass? This is not a retreat to the past, but an application of its deepest wisdom to our future. The principles of localized management, resource recovery, and viewing a city as an interconnected metabolic system offer powerful tools for building resilience. They suggest that the health of a 21st century city may depend less on building bigger pipes and more on designing smarter loops, rediscovering the ancient truth that a city survives not by what it throws away, but by what it keeps in cycle. The story of ancient sanitation is a testament to parallel genius. Across continents and millennia, separated by vast oceans and unshared languages, the great urban pioneers arrived at the same profound conclusion. A thriving megacity could not be built on temples and trade alone. Its true foundation was a silent, flowing agreement to manage water and waste. From the gridded streets of the Indus to the rain-capturing pyramids of Teotihuacan, these civilizations did not merely stumble upon similar ideas. They each confronted the same non-negotiable equation of dense human life and independently engineered brilliant, effective solutions. This repeated pattern reveals a fundamental truth about human progress. It is not a linear march from primitive to advanced, but a recurring emergence of sophistication whenever societies reach a certain scale and ambition. The Roman model, for all its imperial grandeur and lasting influence, stands not as the origin point of this wisdom, but as a powerful, later chapter in a much longer evolutionary chain of urban engineering. Their true innovation was one of monumental scale and systematic replication, amplifying principles that were already ancient history. What ultimately united these diverse systems was a holistic vision that modern cities often struggle to replicate. Success required more than clever pipes or sloped streets. It demanded the seamless integration of practicality, administration, and deep culture. The engineering had to work flawlessly with the physics of gravity and water. But that technology was useless without a social framework, a shared civic contract, and an administrative authority to maintain it for generations. And both the physical system and the social contract were fortified by something even stronger, a cultural narrative that linked cleanliness to cosmic order, spiritual purity, or divine favor. This three-part fusion, the practical, the political, and the sacred, created resilient systems that sustained urban life for centuries. They understood that a city is an organism, and its health depends on every part working in concert, from the grandest canal to the humblest daily habit. This journey into the past invites a curious look at our own present. It asks us to reconsider what we label as innovation. How many of our modern solutions, from urban design to resource management, are actually rediscoveries of ancient, time-tested principles. The next time you turn on a tap or flush a toilet, remember you are participating in a ritual of urban survival that is thousands of years old, a story written not in scrolls, but in brick, gradient, and the enduring human desire to build a healthy home together. What other hidden histories of everyday ingenuity are waiting to be uncovered? The mysteries of how our ancestors solved the fundamental puzzles of life remain a deep well of insight, reminding us that the most advanced societies are often those that best remember the lessons buried beneath their feet.